So the topic is queue. Queue is a linear data structure. Queue works on FIFO principle. What is FIFO? First in, first out. Again, this is a logical data structure. Here you might have seen lot of situations. There is a particular service station or a counter. People comes for service. They will have to wait for the service because the service station may be a little bit time consuming. So the first person who comes first will get the service first from the counter, and as the people comes, they will stay rear to the person in the queue, and the person comes first. He will be at the front position, get the service first. So the first come first serve, first in first out, we can also call it as first come first serve. This is the policy, first come first serve. The person or the item that added into the queue first will get first service, or the item which is added first will be deleted first. So that is first in first out, FIFO. So queue has two ends, namely front and rear. A queue has two ends, namely front and rear. If you observe a queue, you can see the service get to the person at the front of the queue, and the person in the last part of the queue will get service at the end. So the item will be, in a queue, the item will be added to rear end, and service will be or provided, or deletion will be done from the front end. Two operations defined on queue are insertion and deletion. Two operations are defined on queue, namely insertion and deletion. Insertion takes place at rear end. Insertion takes place at rear end, that means the back end. And deletion takes place at front end. A new item into the queue will be added at the rear end, and deletion will be performed from the front end. Now, if there is no item in the queue and performs a delete operation, we get queue underflow message. If the queue is empty and one tries to delete an item from the queue, it generates a condition, or the message generated will be queue underflow. If the queue is full and performs an addition, performs insertion, operation, the situation is queue overflow. If the queue is full and one tries to perform an addition operation or insertion operation into the queue, then we will get a queue overflow message. Again, this queue can be implemented using array as well as some dynamic method of memory allocation. Here we are going to see how a queue is implemented using an array. So let this be our array. Let this be our array. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here the size is 10. Two ends are there. We have front end and rear end, and this array is named as Q. Let Q be the array. Name of the array is Q. Now if you are performing an insertion operation, or we are going to add an item into the queue, so there is chance either the queue will be completely empty or the queue is half filled or the queue is full. So we have to check whether there is space in the queue or not to accommodate a new item. So we have to check whether the rear is the value of rear. Based on that we will take the decision. If rear equal to -1, this is one condition, then rear equal to -1 means there is no item in the queue is empty. Then we have to set the front and the rear, that is front equal to 0, rear equal to 0. So only one item in the queue. That item is the item at the front as well as item at the end or the rear. So queue of rear equal to value. Let value be, we want to val be the value that want to insert into the queue. else if it is not -1, which means it is not empty or it may be half filled, else if real less than size -1, which means if it is half filled and there is space in the queue, in that condition real equal to real plus 1 and q of real equal to 1. Else if both these conditions becomes false, that means it is not an empty queue or it is not a half filled or a queue having some space to accommodate an item, which means the queue is full. In that case, print queue overflow. And if. So this is the algorithm for insertion into performing insert operation into a queue. So let us check. So here initially friend equal to -1 and rear equal to -1. There is no item in the queue. So if rear equal to -1, yes, then friend equal to 0, rear equal to 0. Here f as well as rear is 0. That is the initialization. Q of rear equal to val. Suppose the item into the queue is say A. You are adding A into the queue. So that is added. So only one item in the queue, front and rear are the same. And again another item comes, say P comes. Let P be the value to be inserted into the array. Again we check the condition. If rear equal to -1, no, that condition is false. Else if rear less than size -1, yes, rear is 0 now and size -1 is 9, which is less than 9. So rear equal to rear plus 1. So what happens? This rear is incremented. Rear comes here and q of rear equal to value. So the value is p. That value will be inserted. And now again comes say x new value. Condition is checked. So what is rear now? Rear is 1. Rear less than size -1? Yes. So rear equal to rear plus 1. So rear becomes here. This is rear. Then that value will be added. And that continues. And now suppose we have A, B, N, R, D, some values like this. C here. Now this is the rear. What is rear now? Let rear be. Rear is 8. Now we are going to insert another item, say W. So again this condition is whether rear is -1, no. Rear less than size -1. What is rear now? Rear is 8, which is less than 9. W. So rear equal to rear plus 1. Rear becomes here. This is rear now. And q of rear equal to value. What is W? That is W. That's value is W. No problem. Again, another item comes. Say let it be Z. So rear -1? No. If rear less than size -1, what is rear now? Rear is 9. Whether it is size minus, what is size? Size is 10 minus 1, 9. Whether it is less than 9, no. That condition also false. Else print Q overflow. Now the Q is full. So the message Q overflow will be generated. So this is the algorithm for insertion of an item into the queue. So this can be converted into C++ code, something like this. The queue is a global array, size is a global variable, front and rear are global variables, and suppose we want to insert an item into the queue. So what we have to do? We are writing void insert. We have character value char says C. So, yeah. Okay. Now we have to check if rear equal to -1. If so, what we have to do? Front equal to 0, rear equal to 0, then q of rear equal to the value. Else, if rear less than size -1, then rear equal to rear plus 1, q of rear equal to 12, else cout q power 4. So this is the C++ code for implementing Q. Now we are going to perform the delete operation. Delete operation, the deletion will be taking place from the front end. So if the front is greater than -1, it means there is item in the queue. So the front item at the front will be deleted from the queue. So we will check if front greater than -1. If front greater than -1, then what we have to do? The item at the front will be deleted. So we have to print, say, print q of front. Now front is to be incremented. Front equal to front plus 1. Else, if the front is not greater than -1, it means there is no item in the queue. So we can print, give the message print q underflow. And if now we have to perform one more checking. Basically this is okay when the front increments and goes beyond this rear, we have to reset the front and rear. So if front greater than rear, then front equal to -1, rear equal to -1 in if. Let us see how this works. Suppose for the time being this will be our rear. This is our rear. Then this be our rear. Now, if the front greater than -1, in this case we have the queue having size 10 and we have 4 items in the queue. The firstly entered item is A, so it is the front at the front, and the lastly entered item is A. So for the time being, it will be E, and it is at the rear end. Right. Now, if front greater than -1, front is greater than -1, then we have print the queue of front. That is, A will be deleted from the queue. A is deleted. Then front equal to front plus 1. What happens? This front becomes here. Now this is the front. The next item to be deleted is here. Again, you are calling a delete operation. What happens? Now the front is greater than -1. Again, front is 1 now. So P will be printed. P will be deleted. Now again, this front moves to here. Again performs the delete operation. Deletion takes place at the second position, that is index number 2, that is front is 2, that is X is deleted, and front is again incremented. Front and rear becomes equals. Then again front greater than -1, yes, Q of front, that is E will be deleted. Then front equal to front plus 1. So here front becomes here. That front becomes more than rear. So what happens is this condition will get satisfied if front is greater than here. Yes. Then front equal to -1, rear equal to -1. That is, both of these will be reset to -1. Front equal to rear equal to -1. Reset will be done. Now the queue is again empty. Now suppose we are going to add a new item. What happens? Checks whether it is empty or not. Yes, new item, front and rear will be here. Front, rear will be here. So this item will be. Now we will try to write the code, C++ code for this. We can write, this is a character array for, so that we are returning character value car delete. Okay. Now say we are deleting that value be the value to be returned, and if front greater than -1, value equal to, another way of writing this code, we used some another method in the case of stack. Value equal to q of friend plus plus. If this is not the condition, else cout q underflow. There is no item to return q underflow. Now we have to reset this. If front greater than rear, then front equal to -1, rear equal to -1, and finally we have to return that return. So this function can be used for performing delete operation on a queue. So this is the simple logic for delete operation. Now, what are the applications of queue? See, there are a lot of applications. In computers, we use it for scheduling, job scheduling, memory scheduling, etc. So, real-time example is a printer. A printer is a slower machine compared to the computer. Suppose we are giving print jobs, what happens? The first job will be printed first. Suppose we have 3 documents to print and we have opened the first document and given the print command and it started printing. Suppose that first document has 10 pages and by the time we have opened the second document and we have given print, and after giving that print we have opened the third document and given the print command. What happens? The printer has just started printing the first document. Its second or third page is printing. By the time we have given 2 more commands to print 2 more documents. So this will be put in the queue. First document, then the second and third document will be put in the queue. Then the printer processes one after. The print job will be done one after another. So this is an example for job scheduling, print queue scheduling. So such memory scheduling, process scheduling operations can be performed with the help of queue concept. Now we have one more thing in this. That is the circular queue. Circular queue. See, this queue implementation has a limitation that in some situations, the problem is with our code, in some situations, even if there is space in the queue, it will generate queue overflow message. Suppose, let this be the condition. So we have friend here, P, X, A, B, C, and this is real. See, actually we have 10 locations, 10 items can be accommodated in the queue. Now suppose this is the situation, rear is at 9. If we try to perform insertion operation on this queue, what happens is, since rear is the maximum, that is at the size, this will give us a message that queue is full and queue overflow message will be okay. So here we have spaces. Now suppose in this case also, this is the last item, front and rear are the same. Here again we are checking whether rear is maximum or not. If it is maximum, it will generate queue overflow message. So here this is the worst case. So this situation can be avoided with the help of a queue called circular queue, in which we will connect the 2 ends of the queue. That is, it will be something like this. This is our queue. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Logically we are connecting this. Now suppose this is the rear and we have C here, P, X here, and this is front. Now, in circular queue, a queue which has the two ends of linear queue connected together is a circular queue. In this case, we make the logic that if there is space after this, what happens? We will switch the rear from the last value to the first location. So, if we want to add a new item, what happens? Rear becomes 0. Rear will be reset to 0, and we will add the item. So it will be n. So in this case, in the case of circular queue, if we are rearranging the logic like this in a way that we can move from the last position to the first position, if it shows queue full message, as in the case of linear queue, we can use the entire space in the queue. So we can overcome the problem, the demerit with the linear queue, that it shows queue overflow even though there is space available to occupy new item. So such a queue is called circular queue. We will make some changes in the logic of the insertion and deletion algorithm. So this can be performed